You know that feeling, right? You're facing some challenge, could be big, could be small, and you're just
Mm.
not quite sure how to tackle it.
Uh-huh.
That moment where the goal, yeah, it's crystal clear, but the path to actually get there, it feels completely, well, opaque.
Yeah, that fog.
That right there, that is problem solving in action.
That's the moment.
So today, we're not just, defining it, we're taking a real deep dive into how our minds actually navigate these things.
Mm.
You shared some incredible sources with us, and our mission here is basically to pull out the most important bits, the nuggets of knowledge.
Yeah, distill it down.
Exactly. Give you a shortcut to understanding how we find solutions and maybe more importantly, how we can get better at it.
Indeed. And what's truly profound, I think, isn't just getting to the end point, the solution.
Right.
It's the intricate dance of cognitive stuff involved, all the thinking behind it.
Mental gymnastics.
Pretty much. We'll be peeling back the layers, looking at the mental architecture, the strategies we use, sometimes surprising ones.
And the roadblocks too, I bet.
Oh, absolutely. The common pitfalls.
Yeah.
It's all part of that journey from problem to solution, and we'll be guided by the insights in those sources you mentioned.
Okay, awesome. So we'll cover everything from how we even frame a problem in our heads
The mental setup.
to the really powerful strategies we use, those roadblocks we just mentioned, and what actually makes some people true masters at this stuff.
Make experts, yeah.
Get ready for some hopefully genuine aha moments. Might change how you think about, well, thinking.
Let's hope so.
So let's begin right at the foundation, defining what a problem even is.
Okay.
At its core, problem solving is a goal-directed activity. That's the key phrase.
With directed.
Yeah. It's about finding a sequence of actions, the sources call them operators.
Right. And the moves you can make.
To bridge that gap between where you are now, the start state, and where you want to be, the goal state.
A to B.
Exactly. It's that basic human thing.
Yeah.
Knowing what you want, but not immediately knowing the steps to get it. Like needing to get to point B, but oops, no map.
Precisely. And from a cognitive psychology view,
Yeah.
it's very much an information processing thing.
Okay.
Like Newell and Simon, the pioneers in this field, they described it really well. We face a problem when we want something, but the series of actions isn't obvious.
Makes sense.
But, and this is often overlooked, a really critical first step is breaking down that big goal
Ah, yeah.
into smaller, more manageable sub-goals. It's usually not one giant leap.
More like a series of hops.
Exactly, calculated hops.
That makes so much sense. And okay, this leads us to a really interesting concept, the problem space.
Yes, the problem space.
Yeah.
Crucial idea.
So imagine all the possible situations a problem could be in, the start, every single intermediate step you could take, and the final goal.
The whole landscape.
Yeah. The sources say visualize it as search graphs or search trees, like this huge web of possibilities.
The mental maze, you could say.
Right. And the solution is just finding a good path through that maze.
Exactly. And the operators you mentioned, those are the specific actions that let us move from one point in that maze, one state to another.
Picking up a tool, doing a calculation.
Having a conversation, yeah. These are our levers for change. We might discover them by trying stuff out.
Trial and error.
Or someone tells us,
Yeah.
or we see someone else do it. Observation.
Okay.
But the real challenge isn't just knowing the operators exist. It's choosing the right one at the right time.
Picking the best move.
And sometimes, maybe even not doing something. Avoiding an action that might mess up your progress. It's not just moving forward. It's moving forward smartly.
Right, effectively. Okay, shifting gears a bit. The sources are super clear that how we mentally process or represent
Right.
the problem is critical.
Absolutely fundamental.
It's not just the facts out there, it's the internal model you build in your head.
Your mental blueprint.
Yeah. Based on your knowledge, your experience, that internal map dictates everything that follows.
And this is where it gets really insightful. Think about the problem-solving triad the sources mentioned.
Okay, the triad.
It shows how your problem representation, your background experiences, and your understanding of the problem structure aren't separate things.
They interact.
Constantly.
Yeah.
They're in this dynamic interplay, always refining each other. It's like a feedback loop.
Ah, okay.
And this refinement, this loop, it's what drives learning transfer.
Which is?
Your ability to take what you learn, solving one problem, and apply it to a new but similar one. Jonassen really emphasized how critical that initial representation is.
So if you mess up the representation.
Even the best strategies might fail. You're solving the wrong problem, essentially.
Wow. Okay. So it's not just knowing the pieces, it's how we mentally arrange them, the connections we make.
Precisely.
The sources really hammer this home. Can you give like a concrete example? How a bad representation can just derail everything, even on a simple seeming problem?
Oh, absolutely. The classic is the 9-dot problem. Remember that one?
Vaguely. Connect 9 dots.
Yeah, 9 dots in a 3x3 square. You have to connect them all with 4 straight lines without lifting your pen.
Okay, sounds tricky.
And most people initially represent it by assuming they have to stay inside the imaginary square the dots make.
Right, you draw lines within the square.
That's the self-imposed constraint, a misrepresentation. Once you realize, or someone tells you, that the lines can go outside the square.
Uh-huh. Then it works.
Suddenly, the solution is obvious. It just highlights how often the problem isn't the task itself, but the limits we put on our own thinking without even realizing it.
That's a perfect illustration. The mental model just opens or closes doors to solutions. Okay, so let's talk strategies. How do we actually navigate this problem space?
Right, the methods.
One common one, though maybe a bit short-sighted sometimes, is difference reduction, or hill climbing.
Hill climbing, yeah. Familiar idea.
You basically just choose actions that seem to immediately reduce the difference between where you are and where you want to be, always taking steps uphill towards the goal.
Feels intuitive.
Yeah, but maybe not always the best path.
And that's the catch. Hill climbing is simple, often works for simple problems, but it can trap you
How so?
in what's called a local maximum. Imagine climbing hills to find the highest point in a whole mountain range.
Okay.
Hill climbing takes you to the top of the nearest hill. But what if there's a much taller mountain peak hidden behind a valley?
Ah, you'd have to go downhill first to get there.
Exactly. You might have to temporarily increase the difference, go downhill, to eventually reach the real goal, the global optimum. So it raises the question, what if the direct route isn't best or hits a dead end?
That's a fantastic point, and I guess that's where means-ends analysis comes in, which sounds much more strategic.
It is much more sophisticated.
So with means-ends, you identify the main difference, the big gap between current state and goal state.
Right, the primary obstacle.
And then this seems key. You set sub-goals to overcome whatever is blocking you from reducing that difference.
Precisely. It creates a hierarchy.
So like the example in the sources. Goal is be at the store, but you're at home, and the car won't start.
Okay. The obstacle is the dead car.
So a sub-goal becomes get the car working, which might even need another sub-goal like get a new battery.
Exactly. It allows for temporarily moving away from the main goal, if needed, to achieve a crucial sub-goal. The General Problem Solver, GPS, that early AI program,
Yeah.
it famously simulated this means-ends approach.
Wow. So it's like constantly breaking the problem down.
It's essentially recursive. You ask, what's the biggest hurdle now? And then you turn that hurdle into a new, smaller problem to solve.
That feels powerful for complex multi-step stuff.
It really is, especially when a simple straight-line approach just won't cut it.
Okay, so beyond these systematic strategies, we often use analogies, right? Remembering a similar past problem and adapting its solution.
Yes, a cornerstone of human thinking.
And this ability, linked to our prefrontal cortex, is considered pretty uniquely human. But here's the kicker from the sources.
What's that?
We often fail to use analogies that could help us unless someone explicitly prompts us.
It's true and counterintuitive, isn't it?
Totally. It's like the knowledge is there, but we don't connect the dots. Why is that, and how can we get better at it?
Well, it seems our retrieval cues are often very context-specific. We don't automatically scan everything we know for parallels.
So we need a nudge.
Often, yes. Or a deliberate strategy. That's why good problem-solving training often includes exercises like analogy generation. Forces you to build that bridge.
Like actively asking, what is this similar to?
Exactly. Making that cross-domain leap is a skill you can practice. And Holyoake and Thagard's multi-constraint theory helps explain why some analogies work better than others, too. Similarity in the domains, the underlying structure, the goals involved. It's not just any similarity.
Fascinating. So be deliberate about looking for analogies. Got it. Now, sometimes the goal is clearer than the path from the start.
Right.
That's where working backward comes in handy. Start from the desired end state and reason back to where you are now.
Illuminates the steps needed.
Like that water lily problem. If a lily pad doubles daily and fills a pond in 30 days, when is it half full?
Ah, yes. Working backward makes it easy.
If it's full on day 30 and it doubles every day, It must have been half full on day 29. Simple when you work backward.
Exactly. Especially good for problems with clear end states and reversible steps.
Mm.
And related to that is restructuring and insight.
The aha moment.
That sudden flash,
Yeah.
where you fundamentally change how you see the problem. It's about breaking out of what they call a negative set.
Those mental ruts we get into.
Yeah, and reframing the problem based on its deeper structure.
Yeah.
Like suddenly seeing the 9-dot solution by thinking outside the imaginary box.
Okay, and what about incubation? The idea of stepping away from a problem for a while. Does that actually work?
Incubation.
Yeah.
It's appealing, right? We've all felt like we solved something after taking a break.
Totally. But the science is mixed.
It is a bit ambiguous. Some theories suggest subconscious processing, maybe spreading activation to less obvious ideas. Others argue it's simpler. You just reduce frustration, forget the bad approaches you were stuck on, and come back fresh. Less mental fatigue, less rigidity.
So maybe it doesn't matter why it works.
The practical takeaway might just be sometimes taking a break really does help, regardless of the exact mechanism.
Okay, fair enough. But even with all these strategies, we still get stuck. Let's talk roadblocks.
Yes, the common obstacles.
A big one is functional fixedness. Look at something and only see its usual purpose.
Oh, all the time.
Even when you desperately need it for something else. That's it. It stops you from being creative. Seeing a brick only as building material.
And not as a potential paperweight or a doorstop.
Or, yeah, maybe even a weapon in a pinch. It reminds me, I once needed a hammer. Couldn't find one. Took me ages to realize that heavy wrench right next to me would work.
Huh. It's almost comical how our brains do that. It's a prime example of how prior experience, while usually good, can also trap us.
Blinds us to alternatives.
Exactly. And similarly, there's negative set, also called set effects.
Okay, what's that one?
It's our bias toward using a familiar problem-solving method, even when a different one would be way better or faster.
Like if you solved 10 math problems one way.
You automatically try the same method for the 11th, even if there's a shortcut staring you in the face. Our existing mental habits can make it really hard to switch gears.
Okay, so we have these strategies, but also these mental traps, which brings us to experts versus novices.
Right. What makes the difference?
It can't just be knowing more facts, can it? Though I guess that helps. What's the secret sauce?
That's where it gets really interesting. Research shows experts develop automaticity for the basic stuff.
Meaning they don't have to think about it.
Exactly. Frees up massive mental resources, like a chess grandmaster, not consciously thinking about how a pawn moves.
Okay, what else?
They perceive problems differently. A novice sees surface details. An expert sees the underlying principles, the deep structure.
So they categorize problems differently.
Yes. Which lets them apply better strategies, often analogies based on that deep structure. They also engage in strategic learning, how to organize their whole approach, and tactical learning efficient ways to do specific parts of the problem.
So it's not just the amount of knowledge, it's how it's organized and used.
Precisely. Their knowledge isn't just vast, it's incredibly well structured. The sources mention semantic networks, semantic memory.
Or general knowledge of the world.
Yeah. For experts, it's deeply interconnected, allows for super efficient retrieval, connecting relevant bits of info, integrating new stuff easily. It's like a highly optimized internal search engine.
A powerful asset.
Absolutely.
Yeah.
And this links directly to how memory works in all this. It's not just about memorizing facts.
Right.
Things like elaborative processing are key. That means embellishing information, linking it to what you already know, making it meaningful to you.
Not just A equals B, but maybe a story about it, or visualizing it.
Exactly. That makes it stickier, much easier to access later when you need it for a problem. We also constantly make inferences.
Inferences, like assumptions.
Educated guesses, basically.
Yeah.
Filling in the gaps beyond the literal information to really understand the problem.
Okay. Can you break that down more?
Sure. We make backward inferences, like a detective figuring out what must have happened based on clues, connecting the current situation to prior knowledge.
Okay, working backward from the fact.
And forward inferences, more like a chess player thinking, if I do this, then X will likely happen, leading to Y. Anticipating consequences.
Gotcha. Both seem vital for complex stuff.
They really are. Helps us navigate, fill in blanks, predict outcomes.
So it sounds like our actual problem-solving skills develop in stages, like learning any other skill.
That's right. There's usually a cognitive stage. First, learning the facts, the rules, understanding what to do.
Declarative knowledge.
Then an associative stage, starting to link actions to outcomes, getting smoother, making fewer errors. The knowledge becomes procedural, how to do it. And finally, the autonomous stage, where it becomes almost automatic, fast, efficient, requiring little conscious thought, like learning to drive.
First, you think about every single thing.
Then eventually, you just drive. That progression from effortful to fluent is key in problem-solving expertise, too.
Okay, and one last piece, which feels crucial, bringing it all together. Metacognition.
Ah, yes. Thinking about thinking.
Our awareness of our own thought processes, knowing how we understand, choosing strategies, monitoring if we're actually making progress.
It's like having that mental coach inside your head, the executive function overseeing the whole operation.
Guiding and optimizing.
Precisely. Metacognition is that internal voice asking, is this working? Am I stuck? Should I try something else? Do I really get this? It's the ultimate self-correction tool.
And for you listening, that seems like a key takeaway.
Absolutely. You can actively cultivate that inner coach. Pause, reflect. Don't just blindly push ahead. That's how you really level up.
So, wrapping this all up, what does it all mean? We've gone from the basic definition through mental models, powerful strategies like means ends and analogy,
Hit the roadblocks like functional fixedness and negative set.
looked at what makes experts tick and the inner game of memory, skills, and that crucial metacognition.
And what we've seen, I think, is that problem solving is this goal-directed search within a mental problem space.
Right.
And it's hugely influenced by how you first represent that problem, the strategies you pick, and your background knowledge, how deep and organized it is.
Understanding these mechanisms.
As the sources really illustrate, that's the key to becoming more effective, more adaptable, just a better solver in all parts of life, really.
So here's a final thought for you to chew on as you go about your day. Consider this. What everyday problems might you be tackling with a negative set right now?
Stuck in an old groove.
Yeah, maybe using an old approach that doesn't really fit anymore.
Yeah.
And how might just restructuring your view, like looking outside those 9 dots, unlock a surprisingly simple, elegant solution? Or maybe what small area of your life could benefit if you consciously applied a bit of means-ends analysis, breaking down a big goal into those smaller, achievable steps.
The tools are there.
The incredible tools for mastery are all right there, inside your own mind. Now go forth and solve.